we're going to do the second half of the Chapter 8 study guide. What we have here are the 30, 60, 90, 45, 45, 90 triangle examples. And again, I'm going to solve both ways. We're going to use the formulas in a 45, 45, 90 triangle. The legs are equal, and the length of the hypotenuse is equal to the length of a leg times the square root of 2. Also in a 45, 45, 90 triangle, the sides are in the ratio of 1 to 1 to the square root of 2. So I'm going to solve again both ways. Using the fact that the legs are equal, we can say that if this leg is 8, then the other leg, y, equal 8. So we found y. The length of the hypotenuse, x, is equal to the length of the leg, 8, times the square root of 2. And so x is 8 square roots of 2. Well, that was pretty simple. So using the formulas was pretty simple. Let's look at the dimensional analysis approach. The dimensional analysis approach is that I have a leg to start with, and I'm trying to find the hypotenuse. So I have a leg, 8 over 1. So I need to lose the name leg and gain the name hypotenuse. I'm going to put my leg ratio with my hypotenuse ratio. The leg number goes on bottom. The hypotenuse number goes on top. So I'm losing the name leg and gaining the name hypotenuse. I then would multiply and get 8 square roots of 2. So that's the dimensional analysis approach using your scale of 1 to 1 to the square root of 2. Okay? A square is a quadrilateral with 4 equal sides and 4 right angles, so that angle is 90. If one side is 5 square root 2, then the other side is 5 square root 2. If we use this little right triangle to find the diagonal, or we could have used the other right triangle, we know that we've got a 45, 45, 90 right triangle. We know that the legs are equal, so if one side is 5 square root 2, they're all 5 square root 2 in a square. In the 45, 45, 90, the hypotenuse is equal to the length of a leg times the square root of 2. So hypotenuse y is equal to leg 5 square root 2 times square root 2. Now square root 2 times square root 2 is plain old 2, because what you have is a pair of 2's, and from the pair of 2's out pops a 2. And so you have y equal 5 times 2, or y equal 10. Any questions on number 20 and 21? Okay. 22 through 25 is using the 30, 60, 90 triangle formulas. In the 30, 60, 90 triangle, the long leg is equal to short leg times the square root of 3, and the length of the hypotenuse is equal to the length of the short leg times 2. The ratios in a 30, 60, 90 triangle is 1 to 2 to the square root of 3, where the short leg number is 1, the hypotenuse number is 2, and the long leg number is the square root of 3. Using the formulas, what we're given on this first one is the long leg 8. The long leg is opposite the 60. So we're going to put that in place of long leg, and we're going to have long leg 8 equals short leg x times the square root of 3. We would then undo multiplication by division. So we divide square root 3. So that gives us x equal 8 divide square root 3. You can't have a radical in the denominator, so we're going to rationalize the denominator, which gives us 8 square root 3 over 3. The hypotenuse, y, is equal to the short leg, which we just found out was 8 square root 3 over 3 times 2, understood to be over 1. And so we multiply. When you multiply the numbers, and you multiply the names, and you get a new name, but there is only one name, so you just tack it on. And so we have y equal 16 square root 3 over 3. The hypotenuse is twice the short leg. Okay? That's using the formulas to solve with. Let's look again at how to use the dimensional analysis approach to solve. And I keep wanting to talk about that because a lot of the standardized testing now is scale factor driven. It's dimensional analysis driven. So let's say that, okay, they gave us the long leg and we want to solve for the hypotenuse. See, there's not even a hypotenuse long leg formula. So we could say, okay, we started with the long leg, 8 over 1, and we want to lose the name long leg and gain the name hypotenuse. My long leg number in my ratio is square root 3. My hypotenuse number in my ratio is 2. I'm losing the name long leg and gaining the name hypotenuse. So we multiply and get 16 over square root 3. We rationalize the denominator, and we get 16 square root 3 over 3. So even though there's not a formula that takes us from long leg straight to hypotenuse, we could use the dimensional analysis approach with our ratios and go straight from long leg to hypotenuse. Okay? All right. Numbers 24 and 25. So I lost it there just a second. It jumped on me. There it goes back. Okay, let me wide out some working space. 24 and 25, we have a 30, 60, 90 triangle, so we're going to use our 30, 60, 90 formulas. Long leg equals short leg times the square root of 3, and hypotenuse equals short leg times 2. What they gave us was short leg 9. The short leg is opposite the 30. So the short leg 9 is opposite the 30. So we can put that in short leg both places, short leg both places. So long leg x equals short leg 9 times the square root of 3. So x is 9 square root 3. Hypotenuse y equals short leg 9 times 2. So y equals 18. Let's say we got that, number 24 and 25. Okay? Special right triangle rules, 30, 60, 90, 45, 45, 90. You need to memorize the formulas and memorize the ratios. I need you to be able to use the formulas to solve, and I need you to be able to use the dimensional analysis approach or the scale factor approach to solve. Okay? So now we're looking for missing lengths and angle measures of non-right triangles. Before we do 26 through 29, let's go ahead and do the sine, cosine, and tangent ratios just to remind ourselves of that. Remember that the tangent ratio is the length of the leg opposite the angle, so it'd be the length of the leg opposite angle y over the length of the leg adjacent to angle y. here's angle Y. The leg opposite is 12. The leg adjacent is 5. The sine ratio is the length of the leg opposite. So if we want sine angle Y, it would be the length of the leg opposite angle Y over the hypotenuse. The leg opposite angle Y is the 12, and the hypotenuse is the 13. The cosine ratio is the length of the leg adjacent to the angle. So cosine Y is equal to the length of the leg adjacent to angle Y over the hypotenuse. The leg adjacent to Y is the 5, and the hypotenuse is 13. The sine and cosine of complements are equal. So the sine of angle Y is equal to the cosine of angle Z. We know from the theorem that says the sum of the angles of a triangle is 180 that there's a corollary that says the acute angles of a right triangle are complementary. So these angles are complementary, meaning their sum is 90. The sine of an angle is equal to the cosine of its complement. The sine of an angle is equal to the cosine of its complement. Let me just show you that. We're still in degrees here. If I said sine 20 degrees, well, what's the complement of 20? Well, it's 90 minus 20, which is 70. So cosine 70 should be the same as sine 20. See that? Let's do another one. Sine 30. What's the complement of 30? Well, it would be 90 minus 30, which is 60. So cosine 60 should be the same as sine 30. See? So the sine of an angle is equal to the cosine of its complement. All right. So we've got those ratios. Tangent is the length of the leg opposite over the length of the leg adjacent. Sine is length of the leg opposite over hypotenuse. Tangent is length of leg adjacent over hypotenuse. Again, some people like the acronym SO, CA, TO, put all that together. Sine is leg opposite over hypotenuse. Cosine is leg adjacent over hypotenuse. Tangent is leg opposite over leg adjacent. Sine is leg opposite over hypotenuse. Cosine is leg adjacent over hypotenuse. Tangent is leg opposite over leg adjacent. You might like the acronym to memorize. Don't forget when you say opposite adjacent, don't just say opposite adjacent. Say leg opposite, leg adjacent, leg opposite, hypotenuse, leg adjacent, hypotenuse. Okay? All right. So number 26 through 29, we're going to use those trigonometric ratios to solve these right triangles. Now, we cannot use the Pythagorean theorem on 26 through 29 because we don't know two sides and looking for a third side. On 27, we know two sides, but we weren't looking for the third side. Okay, these are not 30, 60, 90, 45, 45, 90 triangles, and so we can't use those special triangle rules, so we have to use a trigonometric ratio. Remember that the first thing we do is identify the acute angle that we're dealing with, and so we're dealing with the 35-degree angle. So we find the angle first. And then we look at the sides given and see how they're related to the angle that we chose. Now, these are both legs. The 8 is a leg that makes the angle, and so it's the leg adjacent to the angle. The x is opposite the angle, and so it's the leg opposite. So we think what ratio had leg opposite, leg adjacent, and that ratio is the tangent ratio. So the first thing we do is we find an acute angle. The second thing is to look at the sides we're dealing with and see how they're related to the angle that we chose, and that tells us which function to choose. The third thing we do is say what that function says to put the fraction in the way it's supposed to be. Tangent says leg opposite goes on top, leg adjacent goes on bottom. Tangent is leg opposite over leg adjacent, so our fraction is x over 8. Once our trigonometric ratio is set up, we're going to solve using the order of operations. So we're going to do anything we can to simplify, and we can do tangent 35. Now we're going to go ahead and do this and round as we go, which isn't the best way to do it if we want accuracy, but we're going to go ahead and do that here. So we're going to do tangent 35. You would need to make sure your calculator's on degrees if it's been cleared. Tangent 35 to 4 decimal places, 0.7002. So we're going to have 0.7002 is equal to x over 8. We then would undo division by multiplication. So we would multiply both sides by 8, and we would get x equal. We're going to have 8 times 0.7002. Rounded is 5.6. Any questions on number 26? Okay. Number 27. Let me clean that up. All right, we're looking for the angle x. So that has to be our angle because that's what we're looking for. We want to see how the sides given are related to that angle. The 7 is the hypotenuse because it's the side across from the right angle. The 4 is a leg. It's the leg across from or opposite. So we have leg opposite the x and hypotenuse. Leg opposite hypotenuse is sine. So then we do what sine says to set up the fraction. Sine says you put leg opposite 4 over hypotenuse 7. Sine is leg opposite hypotenuse. So we get our trigonometric ratio. Now we're going to do what we can to simplify. We can do that division. So we're going to do 4 divide 7, and we'll take it out 4 decimal places. 4 divide 7 to 4 decimal places is 0.5714. We've done all we can do to simplify. Now we want to undo this function. We undo using inverse properties, so we want the inverse sine function, which is written as sine negative 1. That's the function inverse sine. So we undo a function with its inverse function. So inverse sine cancels sine, just like division would undo multiplication or addition would undo subtraction. So we're going to do inverse sine 0.5714. Second sine for inverse sine 0.5714. 34.85 rounded to 2 decimal places. 34.85. Any questions on number 27? Okay. Number 28. Number 28, the angle given is 50. Let me clean up just a little. I'm going to have to white out over that when I erase. It's bringing up stuff that I wrote over the whiteout the last time. Okay, so the angle that we're dealing with, the acute angle, is 50. We're going to put the acute angle first, 50 degrees. We're going to look at the sides that we have and see how they're related to the angle. The 10 is a leg. It's a leg that makes the angle, so we call it the leg adjacent to the angle. The 10 is the one across from the right angle, the hypotenuse. We have leg adjacent and hypotenuse, which is the cosine ratio. And then we do what cosine says. Cosine says leg adjacent goes over hypotenuse, so leg adjacent 10 goes over hypotenuse x. Now, when the x is in the denominator, then we'll write that as a fraction and cross multiply, create a proportion. So we're going to have cosine 50 degrees is equal to 1 times 10, which is 10. I'm sorry, cosine 50x. Let me back up. Oops. I erased over some whiteout. That kind of makes a mess. So I'm going to have to white out, not erase. Give me just a second to clean house here. All right, so x times cosine 50 is cosine 50x. 1 times 10 is 10. Let's go ahead and isolate first. We're going to get the junk off of x. So we're going to undo what's being multiplied to the x, which is that cosine 50 degrees. And so we're going to have x equal 10 divide cosine 50. This way we can just round at the end. 10 divide cosine 50. 15.56. That's 5 or more. You add 1, drop the rest. 15.56. Rounded to 2 decimal places. Any questions on 29? 28, excuse me. 28, 15.56. Okay. Number 29. Number 29, we're looking for the angle x. We're looking for the angle x. So that would be the angle that we use. We look at the sides and see how they're related to the angle. The 9 is a leg. It's the leg opposite. The angle we chose x. The 12 is the one across from the right angle, which is the hypotenuse. We have leg opposite, hypotenuse. Leg opposite, hypotenuse is sine. we have sine x degrees is equal to, now we do what sine says to set up the fraction. Sine says leg opposite 9 goes over hypotenuse 12. Now it's order of operations time. We do what we can to simplify. We can do that division. So we do 9 divide 12, which is going to give us 0.75. We've done all we can do to simplify. It's now time to undo. We're going to undo the sine function with its inverse function. And so we're going to use the inverse sine function to undo the sine function. The inverse sine function cancels the sine function. So we want inverse sine 0.75. So we're going to do second sine 0.75. We're looking for an angle measure here. The angle measure will be 48.59 degrees rounded to the nearest hundredth, 48.59. And that's the end of the Chapter 8 review. Notice that on this review, on the study guide here, we did not have the law of sines and cosines, neither will it be on the chapter test. That's just an extension of things that I wanted to show you that are to come in trigonometry.